I'm very excited about this. I just had a great discussion with somebody else about this topic, so actually I'm going to tell you what I know about it, but it sounds like I'm going to learn a lot as well. I wanted to, the green, it's supposed to be, the 00 FF00, so it doesn't look as good here. I wanted to, because what I've been working on has specifically been made possible by these contributors. I wanted to name them specifically. There's me, there's Stefan Bidul, there's Winzafon, there's Prajun Gedam, there's Tsuping Chung, who was fantastic and pushed through PEP 658, and E. Durbin, who I haven't met, but was very instrumental in something else that I'll mention later on. So I wanted to mention these because to me, it's very exciting that my work involves other people now, and you'll see kind of why as I go through the talk. Fantastic. So everyone is familiar with this. I'm going to go very quickly through this to introduce the backtracking resolver that was introduced, but a PIP requirement string, and actually this may not be a correct example, but it's what I'm going to use for this talk. Requirement string associates a version to a package name. Constraints, I'm going to call that coalesce if you say the constraints match and then produce something more specific, or they can conflict. For example, less than 22, greater than 22. Is that, yeah, so that's a conflict. And I'm not going to mention features, but they are dealt with, because they're not, I guess, relevant to the purpose of this talk, but they're very cool, obviously. I call this the Dark Ages, and specifically my knowledge of what I call the Dark Ages was I can't find these wheels anymore, but they would have just floating dependencies without any version to constraints at all. And this was great, of course, if you understood why this was the case. Because of PIP's non-backtracking resolver, it makes a little bit of sense, and you're kind of maybe familiar with how to handle it. But it's very difficult if you are the one person who is supposed to, anyway. It was difficult, and one of the things that I'm very interested and excited about, and I'm not going to talk too much about ResolveLib, but I think you'll kind of see why my excitement is kind of related to ResolveLib specifically. I'm not going to go too much about this, but especially one of the things I think is very interesting about ResolveLib, specifically for PIP, is that it's small and easy to audit, and that there's no external dependencies. And again, those were constraints that PIP found useful, which is not going to be the case for every piece of software. But I think it was very interesting that they can achieve backtracking without that. You don't have to, well, I'll go later in the talk. So I'm going to quickly mention what I'm calling related work regarding, again, new resolvers that happened. Oh, by the way, again, just the new PIP resolver is fantastic, and it's now on by default. Spack, of course, there was a talk earlier today. Spack uses Klingo. They do, very, very interesting kind of stuff, and they're of course even thinking of using potentially another one that was released recently. So that's very cool and interesting. Spack's goal is very different from PIP's because Spack's dependency model is different from PIP's, and Spack, I think, Todd went over that earlier today. Pants is a piece of software that I worked on and poured my heart and soul into when I was at Twitter. And it happens. It's not super relevant, I think, because it's more of a build tool than a package manager, but it does use Rust in order to execute Python async functions, and it's very, very interesting because that way we actually had coroutines in Rust via Python before they had them in Rust, and I just thought that was an interesting kind of way to interact with that. And so, of course, everyone's familiar with Conda as well, Pixie, and libsolve, and there was a talk about that as well. But I wanted to contrast, I think, what PIP did, and I'm not saying this is, of course, right or wrong, but at the very least, I want to contrast PIP's constraints to these other tools. This was a great toot from Kat. I didn't ask them how to pronounce their name, but I'm going to say Kat Marchan. And one of the things I liked about it, which I put an arrow next to it, regarding specifically their experiences, again, making their package manager origin work. I really liked the end of this toot, and I'm going to repeat this a couple times actually throughout the presentation. I think the right thing might be to think of higher-level optimizations to the very concept of installation. Now that's, again, in the context of JavaScript especially, and so I'm going to take some poetic license with the term installation, but I think, well, it'll kind of make sense as I go through the talk. But I really liked this toot specifically because, well, I'm going to get you to it. So the motivating problem for the work that I'm about to describe occurred as a result of my work on the build team at Twitter. And I worked very closely with, I've mentioned, Pavan Yalamanchili, who was really fantastic to work with. And one of the things he casually mentioned at one point, not as something to kind of solve, although that was usually the relationship we had, was that, because he didn't, it didn't seem like there was, something to solve there, was that one of the data science teams in Bangalore was having, the number was 30-minute latency to make any change to any code. And these are, of course, data scientists. They're very good at their jobs. They're very smart, and they're unfortunately not able to do their jobs. And I had some notes about, I of course wish Twitter had invested more in data centers outside of the US, but the reason for this specifically was just because Twitter only had data centers physically in the US, and that's just a thing to note about it. But this is something that was really important to me specifically, just because I felt like I was able to, I felt like I was able to fix some sort of US centrism within Twitter at the time, even if, of course, maybe just made it easier for that. Regardless, this is the motivating kind of problem for the work that I'm about to kind of describe, and especially the work that I ended up moving to pip, and especially it was motivated again by this altruistic kind of motive. I call this IPEX. It's not a very, it was based on Basil's kind of iJar. It's not related at all, and I don't think it was a super good name, but it was a name. And it was a particular technique in PEX in order to, well, actually, I apologize. Let me go a little bit back. Everyone's familiar with PEX. Well, I don't know if everyone's familiar with PEX files, but they're a big zip file, and it's got, especially if you're in Python, it's got your dependencies and your source code. These things are usually separate. The problem, especially, and I've mentioned this here, do I have a laser? I don't have a laser. The TensorFlow wheel specifically is greater than 2 GB in size. It has always been the case. It's going to probably be more. I don't think there's a problem with that necessarily, but it's something that you have to deal with, especially. And I'm going to mention how this relates to pip's backtracking resolver later on in the talk. Specifically, one of the things and one of the reasons why I thought this was at least feasible to solve was there's this inefficiency here. When a model is deployed, well, I say deployed, when a user wants to deploy a model, when one of these data scientists in Bangalore, for example, wanted to deploy a model, they would build it locally on their machine with pants. And to do so, they had to download this wheel. Now, they probably already had this wheel cached, but it is often going to happen if because sometimes people had to, erase the pants cache because the pants cache wasn't working. So, unfortunately, this download does occur not only the one way, but especially, and this is the way I wanted to solve, you have to then upload essentially the same TensorFlow wheel compressed inside of the actual PEX. And this is the reason why it took so long, because you're uploading a several gigabyte size zip file. So ideally, the goal was, and this is something that, again, Pavan pointed out to me, so that actually kind of clinched it, was if you can download dependencies within the data center, it's very, very fast. And that made sense to me, but that was not something that I particularly thought of. But that kind of made things come together. And I also want to note, I didn't put his name here, but John Soroas, who's the pants maintainer, very cool guy. He was also very instrumental, actually, in architecting IPEX, and I should have mentioned his name here. So, in this particular case, you can actually, again, I mentioned this more in a more general case, a deploy artifact which downloads dependencies after entering the data center. Here I have the specifics. It was with PEX, you can have a special bootstrap script so that when you execute your zip app, your zip file, it can produce special, it can execute whatever code you kind of want. And in this particular case, we are able to take a JSON file. I think I might go into that in a second, but we were able to remove the dependencies from the PEX file, and then in the bootstrap script, download them in the data center. And so the result, the number, this is less of a numbers talk and more of an ideas talk. So but there's going to be a couple numbers, and this one's relatively simple. It's, well, that's not right. 267K 148. 140, oh, that's K and M. Yes, okay, apologies, yes. So the dehydrated IPEX is much, much smaller, correctly, than in this particular case, I just produced it for a test case. And this PEX file for this test case, which I haven't given you the inputs of, it's much, much larger because, again, it has these dependencies inside. So nothing super, super important there. And again, note that these dependencies are still compressed, but they are still gigabytes in size when compressed. But they're also zip compressed, so anyway. Yeah, I like Langston Hughes a lot, so if you're familiar, it's a great poem. It's also a difficult poem. Right after shipping the IPEX project, I left Twitter for LLNL. LLNL was a fantastic place to work. Twitter OSS, the account on Twitter is unfortunately deleted now, which is unfortunate. And I'm mentioning that only in the context of when I had worked on, especially this, I would say this altruistic kind of motive, especially for the Twitter Cortex team. I think that was part of why I was really motivated, I think, to move it, I think, upstream, specifically because it was written to help people. Now, I'm not saying this is, that was just what motivated me specifically, and I'm mentioning that because I think it leads into the other ways that this ended up moving forward. Yes, oh, and the other thing that's important as well, which is something that I've realized about Pants, is that if you use a build tool like Pants and you make changes to Pants, not everyone can use those changes unless they change their code base to use Pants. So that's something I'm thinking about right now, and especially it leads to, again, this thought of being kind of stuck, for example, or my code being stuck. So. And by the way, does it explode? That's a line from the poem. That's not intended to be anything. So this is, I guess, a quick run through of how I interacted with pip, which is absolutely by far the best product I've ever interacted with, and the maintainers are absolutely fantastic and extremely helpful and patient. I mean that quite seriously. And so when I was at Twitter, and I'll go into one of the silly things that Twitter did, but there was a performance bug because of one of the silly things Twitter did. And so I made a fix to pip previously, and Su-Ping Chung, who's Uranus Jr., was very, very helpful regarding that, and he'll come back in this presentation. You'll see this is the name of the issue that I created, which had a big prototype. You'll see this is not probably a super helpful maybe issue. It was a very, very lengthy issue as well. So what I'm trying to say was, like I said, I had lots of ideas, and it wasn't quite clear how that would kind of turn out. So it's very important to me to emphasize that there was a lot of effort on the pip team side, and I'm going to kind of go into how that relates to how I think about the Python community as well, in general, and then flowers. Okay. So I mentioned, the specific changes that I'm talking about, and that I'll kind of discuss moving into pip are twofold. I never use that word. Pip install -- report. Now it's actually -- report and then a file option. It decouples downloading from resolving. So what I did with the Twitter Cortex team was specifically, there were lots of kind of hacks and workarounds, but the goal especially was to do a resolve beforehand. It was very wasteful in the way that I did it, so that you could get the metadata afterwards in a way that you could extract later. And so pip install -- report is not. It's two things. One, it's the ability to, it's the representation of metadata in a JSON format, but also it's, again, like I said, decoupling downloading from resolving. So it gives you a higher level kind of ability. And then finally, I mentioned how you can, I think in the talk description I said, how you can, I'm going to tell you how you can use these, in your Python programs. For this one, there's nothing you can do. It's just, it's always going to happen. You're going to have some performance improvements in some cases, but especially in cached cases. And so I'm going to go into some more specifics, but I'm not worried about bragging here because it's something that's absolutely kind of going through. But I would love to hear questions about that. So this is a big overview of pip, the JSON install report. So this is something that was, well, okay, so this is this is an example of the command line that works actually in pip right now. You can run it yourself unless you have a very old version of pip. And this is precisely provides things like dependencies, which is, well, actually, that's not correct. Actually, for dependent, for what you want for the IPEX thing, you'd actually want the link to download. So I use this example because it provides the same kind of metadata you would expect from actually having the wheel locally. This was an entirely new API service. Pip's stable API is the command line API, and so. So it was the right thing to introduce it that way, but it wasn't clear where to add it. And especially there was a back and forth regarding whether to put it in the download command or the install command. Stefan was extremely helpful, and especially in discussing that with me, and he was the one who actually implemented the feature and pushed it into production. So I am very grateful to him for that because he of course recognized for me personally, it was great that somebody recognized that, oh, this is kind of useful, and especially in this thread, other people from other corporations were also saying, I would like to be able to use this. So it was very, very nice, that it kind of came gradually, but it was very validating, again, that people kind of took my code and actually kind of ran with it. And of course, there was a lot of effort on my part, by the way, to make that happen, but I'm mostly focused about the effort that other people kind of did and how interesting and useful that was for me. So now, as an update, like I mentioned, the metadata only resolves are not very flashy because they're just mostly caching. I'm going to have a command line that's not super parameterized later on, so you can see an example of the performance. But the important part that I'm trying to describe in this one, and that I was mentioning earlier, regarding backtracking. So the backtracking is something that's necessary, and pip is not doing something pathological here. But when it has to backtrack specifically, that's one case where it has to download currently. Yes, currently, unless currently it still has a downloaded version of the dependency, and this may occur multiple times. And so if this occurs with a very, very large wheel, for example, you may find yourself downloading multiple gigabyte-sized files and throwing them away because the backtracking solver finds a conflict and then has to backtrack. And again, this is not because pip is doing anything pathological here, but it's because we have to download the wheel in order to get the metadata. And so that's the very important kind of I guess, change that I'm going to describe in a second. Goal obtain. So I think I use a funny analogy later on. So I'm going to go back to this. I thought I removed that dash. I'm going to go back to this toot here because regarding metadata only resolves. This is really what I thought about when I saw Cat's toot regarding changing the optimizations to the very concept of installation. We'll move forward, but I want to keep that in mind because I think it's a very, very interesting framing. So one of the ways that I tried to kind of draw blood from a stone was recognizing that zip files have an index that you can scan. And so people may be familiar with the unfortunately currently not very effective use feature fast steps option in pip. That currently implements this approach. And there is a PR that makes it significantly faster that that I think should be linking here if I'm not. But the point of this is that we are trying to, without changing any standards, without making any agreements with anyone, to draw blood from a stone to get metadata where it's not there. And this is actually very useful because a lot of the very largest artifacts are wheels, and so very often, and this will be effective. And I'm going to go into why this is still useful even with PEP 658 later on. And it was like, again, when I said this first prototype, this was again that issue that had all caps and wasn't very well done. So again, I wanted to emphasize that it came from some hacked together stuff, but there was a lot of patience from the pip team that I really respect. Okay, yes, so I called it zip file hackery previously. I'm now going to call it zip file wizardry because I was extremely surprised that the zip file operations that I considered had been made much better. So Winzafon, Mick Senix, MC Senix on GitHub, really cool. For his Google Summer of Code project, he actually made this production ready, and yes, so two things that he introduced specifically was, again, this lazy wheel interface, but the merge part is a little bit less, well, it's less important. It's actually very interesting, but specifically it's providing a readable file object that ends up using HTTP range requests. And the second part is just it does it intelligently and doesn't do things that it's already done. So this is something, framing as a file object and especially doing that performantly was very interesting, and it made it something that was possible to be production ready. I'm not in this talk going to describe again why the fast steps option is currently slow, but I would love to talk to anyone about that if they're interested. And again, I can promise you and show you benchmarks that it's better. That was the initial approach for trying to get metadata, like I've said, drawing blood from a stone. I wanted to apply this same process to other dependencies like sdists, and immediately, anyone who's familiar with Python will know it's kind of a silly. Oh my goodness. Okay, it's kind of a fool's errand, I think. And so, of course, the pip maintainers saw this. They'd seen my PR that was, it wasn't actually super large, but they very clearly linked me to the discussion describing why sdists don't reliably have metadata or don't reliably have it in a specific place. And so 8929 was my attempt to use some very hacky solutions on other types of archives. And it was clear to me that that this wasn't going to work. And so from that, I don't know directly whether it was this issue or whether Tsuping Chung Greenish Jr. had already been thinking about that. But very quickly after I proposed this, I saw PEP 658 on the horizon. And so that was really interesting. And I'm about to go into how that generalized and how that, I think, leads to a much more kind of a nimble kind of pip in the future. So I used the term blood from a stone. I also said medieval alchemy regarding if you can trust getting metadata from Python package. And of course, in the worst case, you have to evaluate Python code. I said the hackery puts on a suit. The reason why I did that is because it essentially took this idea of zip files, of getting metadata out of them, without having to agree with anyone, without having to change any sort of ways. And his name is on it, so I can say he specifically defines a standard. People are probably very familiar with this, but it provides a standard for package repositories like PyPy to provide metadata adjacent to the file. And so this is very helpful. Obviously, if you want to avoid downloading very large files. Pip implemented the client version of that, which I'm about to go into in the next slide. And I believe his name is pronounced Eder, and implemented the server, and I was extremely happy about that for lots of reasons. Very happy. So this is an example of, again, the output that you get from wheel.metadata, which is the new PEP 658 interface. This is not super interesting unless you look at things like requires dist, which allows you to then go on and produce more, progress in the resolver. So, Yeah, I think I actually made this point in the previous slide, but I used some silly language here because I wanted to really make the point. I did not, I think, and really think outside of the box of how can I take what PyPy already kind of has and extend it. And it was really interesting. One, I've mentioned before, it was very validating, of course, that people take my ideas and run with it. But especially to me, separate even from separate from the personal part, it was very interesting to me that something could be formalized and that the problem becomes much easier. And so this is something I think it's very important that I kind of learned, is that relying on a standard is actually worth the effort in many cases. But I'm very glad Zuping-Chung did it for me. Metadata-only dis, it was the generalization of this, and it's the point that I'm trying to make about pip in general is that this first zip file approach and then led to the more structured kind of approach. And I'm about to go into essentially once you have this metadata-only dis, once you have the ability to generalize or shrink down a distribution to metadata-only, and that just means that your resolver can progress without it, you can do really fun things with it. So this is the reason why I'm saying pip is going to be faster. You can trust me or not. Oh, that's unfortunately out of order. That's fine. OK, I wanted to do a metadata-only dis enable caching. I'm not going to go too much into this, but if you can represent a distribution as a JSON, as a single file, you can serialize it, and then you can also then make another dist, fake one, out of it that the resolver can use. You can then cache it. And there's a discussion about how much you should cache, et cetera. And I would love this particular pull request has the PR in progress here. But I wanted to just make the point that once we started from the zip file hackery, and then once we moved on to PEP 658, it opened up, I think, a lot of different things. And I'm about to make another point here. I'm going to quickly go over this, unfortunately, because I don't have much time. But non-PyPy repos, which don't have PEP 658, are, I wouldn't say unfortunately, they're very common, and they're very common within corporations. So I'm not going to go too much into this, but there's lots of reasons, especially like why something that works without PEP 658, such as the new fast steps, is still useful. So I'm going to just blaze over that for a second. And this was a slide I put in later. I'm not going to be able to go into this a little bit much, but you can cache more things. It also works. These are PRs that are in progress that I believe, well, I'm going to make sure that they're accepted, but there are more things that you can cache in pip. And again, I think this comes again from the ability to generalize these operations. Here's the one number that I'm giving, and it was just from my laptop today, and it's representative. I'll explain to you why it's representative specifically. You have the number 9.354 seconds, and you have the number 29.175 seconds. Again, I'm mentioning this to you only because to frame the next part of it, because the reason why this was so different was because the current backtracking resolver, this one here on pip main, will still download every file in case it doesn't work, and it has to do a conflict and has to backtrack. And so this happens with TensorBoard if you try to resolve any TensorFlow GPU wheels very often. So this is the reason why it has to download all of these individual wheels, the actual full files, in order to move forward. And this is the main contributor to this. So again, I understand this is not like a real description that I would put professionally, but I wanted to make the point here that we can directly see the difference in the operations that pip performs here. I'm mentioning this one more time again. Optimization is the very concept of installation. So this is the point I want to make, and so I don't have much time, but I'm going to have to do it right. Essentially, it's IO-bound work, and this is the point that Kat was making. IO-bound work is really hard, and the point that I'm really trying to make, which I may just go directly to the end here, is that often trying to be. It's very fun and interesting. I think to write things in different languages. It was very interesting to me that improving pip performance was not about Python performance. It was about changing I/O and making use of the Python packaging format, and especially making use of PyPy. And the interaction between PyPy and pip, I think, is so interesting. And I want to leave you with this again because I'm out of time. But specifically, one of the things that Cargo does, which is different, which people may not be familiar with. Well, maybe you are actually because you've waited for it. But every single time you run Cargo, it has to pull a Git repository. I've had some notes as to why that's kind of negative. But to me, it speaks. I don't know much about the interactions here, so I'm not trying to insult anyone. But to me, it speaks that there's not a lot of back and forth here. And to me, I want to make it so clear that I was really impressed at how quickly the Python community moved to PEP 658. I was really impressed that it was implemented in PyPy after some controversy, which I'm very glad about, or glad that it's done. And so to be perfectly clear, I want to make it very clear, I use Rust quite a lot, but to me, I made another point here. Basically, I made another point here. Where I actually tried very, very hard to make something faster with Rust, and the I/O is the most important part of it. And so, I think I will leave you with this, and I hope that was interesting to somebody.
Thank you, Danny. I really appreciate it. Having worked on pip a while ago myself, so 3 times.
I hope the green wasn't too hard to read. I like the color, but I apologize if that was the case. So
wait a second. I think we have time for 1 or 2 questions.
Oh, good.
We are running okay on time. Does anyone have a question about the topic? Then Danny wrote.
So something you seem to be alluding to was that the fast steps feature is not entirely useless, even with PEP 658.
That's correct.
And am I correct in surmising that there are subsequent improvements to it that are currently in flight?
That's correct, and I would absolutely love to show the PR specifically. It was work that actually the improvement was not from me or anyone in PIP. It was somebody, I think, he may have been working on Conda. I'm forgetting the name, but I can show you the pull request. So he just figured out that we wanted to reduce the number of HTTP requests. Succeeded in doing it. There was a change. I think I mentioned this to you earlier. There was a change in the way that Pi responded to HTTP requests. So we had to make some small changes to it, but right now, not only is this fast steps operation implemented and much faster, and I've got very, very nice performance numbers for that, but also it's very well documented, and so things like using, it was mentioned earlier, which I think is correct, that using HTTP range requests is difficult. And so there's at least a lot of documentation people want to do something similar in the future. But specifically, yes, there is a fast steps implementation that's actually fast, and that that I turn on if possible. The caching part is also very interesting, but yes, that's correct. It usually does it in like 3 HTTP requests or so, and so in very small ones. And the other one didn't try to do that at all.
Anyone else? Any other question? Okay, thank you, Danny, again. I appreciate it.